Hey Sergey, welcome back.
Uh, Good morning, Adam. Thanks for inviting me again.
Yeah, sure. It had to because today I have also not a question about your computer, rather than what interests me how JAX-RS happened. Because what I remember back then, it was like everything was about SOAP and servlets, and then somehow JAX-RS happened and was even the most popular, one of the most popular specifications of Java E. Do you remember the early days, how the idea was born for JAX-RS?
I think the idea was born by the guys from Sun Microsystems, right? And I think Paul Santos, as far as I recall, who was just driving the initial implementation and was totally revolutionary, right? And Jersey, the early Jersey versions, they really, I think, they've blown everyone away. And I thought that's how it was born. And there were other thoughts happening around at the time, right? So that's specifically about RPC being not the best protocol for scaling up, right? And I thought the whole concept of writing software such that it can reach the scalability level of web, which is what drove invention of JAX-RS.
Oh, so the main driver was not having something nice REST APIs. More the motivation was scalability for JAX-RS.
Uh, this is this is my own interpretation of that. Like, I mean, just having an API wouldn't solve the wouldn't get us closer to reaching the web level of scalability. Right? I thought people were concerned. What happens when you have thousands of clients talking to thousands of servers, and what happens when someone changes a signature in the method, and should we have to redeploy everything, like just because of things like that? And on the web, it was just like from the get-go, just reading unrecognized tags are not causing the browser to fail. So the things were backward and forward compatibility from the early days. So you just you deploy a new version of the server, and the older browser still consume it, or newer browser can still consume old servers, which is the forward compatibility, and it was just working there from the very early days.
So this is we talking about the tolerant reader pattern, right? Like provide
Yeah,
quality, expect crap. So
yeah, but also the flexibility of the API, so that the browser way of doing things, like you are going through the application state by following hyperlinks, and and I think people wanted to create API which would allow people to do things flexibly, like move to the next path, or don't just create a object and do call and it's done. They wanted this flexibility, and for better was, even though like you can't do what you can do in the browser in the Java code, it was still driving this kind of idea of creating a flexible API, and for Java users to
yeah.
appreciate what it's about.
So the scalability is more terms of how to call it, backward and upward scalability that we can tolerate. So we can create bigger apps without how to call
Things.
it, breaking clients, exactly, or the breaking communication partners. So this was the idea. And you said that the Jersey. So was the Jersey first? So had Jersey protocol first, and then JAX-RS came?
I don't actually recall precisely the sequence of events. I think it might have been that Jersey provided the very first kind of proof of concept, and then I think Paul and others from Sun just started opening the specification process and trying to formalize it. Or it might have been the other way around. But to me, it seems like it was actually Jersey just came up with the proof of concept, and people were just totally excited, and they started formalizing it in the specification text. That's
Okay.
my recollection of this, though it might be not quite
Okay.
precise.
And how early you joined the JAX-RS spec?
So the first of all, I wanted to implement it myself, of course. Even though we had some obvious tension at the time that, look, you just have to use what JSON already has, but we already started like Dan and Don Kalp and others from Iona. They already had Apache CXF Software Foundation project activity going, and Apache CXF in particular. And it was only about SOAP at the time, and for Apache CXF users, it was obvious to me and for other CXF colleagues that we wanted to give options to users, right? Because it was obvious that users would want to write from now on not only SOAP-based applications, but they would like to explore JAX-RS. So one of my colleagues from the China office, he started the initial JAX-RS implementation, and shortly afterwards I joined, and from then on I started really quite heavily involved into the whole project. And when did I think I might have joined JAX-RS specification effort only after I joined Red Hat for a brief period of time and returned to Talent to work full time on Apache CXF JAX-RS. And at that point of time, I thought, as far as I recall, that was the first time when I joined formally the specification effort.
What I found revolutionary at the beginning, that JAX-RS was designed to be servlet independent, right? Or somehow servlet independent. Because you could inject, the HTTP servlet request, but actually it was meant to work without servlets, right?
Yeah, and a few of the implementation were servlets.
Yeah, it was
funny.
Yeah.
Yeah.
At the beginning, it really leaked because what I saw also, everyone shipped it with the Jersey servlet. I think it was even hard coded in the first releases, but right now it is actually true, right? So Quarkus JAX-RS works without servlets, right?
Apache CXF, yeah, definitely works without servlets. Servlets will be just one of the integration points, really. Yeah.
Because if you think about this, servlets are not really needed, right? So we have to get the posts, and this is what servlet is doing, is parsing, the parameters. But if you have the information, you don't need servlet. You only need the information which is encoded in the request, right?
Yeah, suppose for some implementation, it was making sense to create them as filters, just so that they had to support servlet communications at the same times for AGB or something else. And for Apache CXF, there's no problem like that. You just really have to worry about.
Yeah, but you could use container request filter, I think, in a container response filter, right? It was,
Yeah, it was something like that. Yeah. True.
Okay, so now at the beginning with JAX-RS, which authentication method we had available? So at the beginning with JAX-RS, So was it something
it was HTTP, basic authentication, I suppose, and then there was Kerberos authentication, like a rock solid, pretty old authentication mechanism. But then, just about the same time, possibly, people were starting talking about Open Authentication 1 nil, and that's where the whole new revolution started, I suppose.
OAuth 1.0, I say, right?
Yeah.
But there were some problems with the
1.0,
spec, right? 1.0. So with the 1.0, there were some problems with the spec, right? So that's a severe problem, I remember.
Well, it probably depends on which camp you were in. At the time, I wasn't very deeply involved into OAuth 1.0 in particular, but it was the whole concept brought by the specification was revolutionary. So you don't have to. It was it was paving the way for mainstreaming single sign-on, expensive single sign-on, just into the making it going mainstream, right? And the authorization, entering the password, was happening not at the website you are about to access, but at the provider side, right? And this is where you enter your name and password or whatever other authentication mechanism is supported by a given provider, and then redirected back. And I thought that was becoming increasingly popular, and this in turn led to Open Authentication 2.0 effort, which I started following a bit more closely at the time. And as far as I recall, the Open Authentication 1.0 author eventually decided to quit, but Authentication 2.0 effort remained, and in the end it succeeded, right?
What I remember, there was Java 1. It was the Monday was the community day. And the community day, you had the possibility to talk to the engineers. So there was there were tables, and you could just join and had a chat, informal chat.
All right.
Yeah, it was a nice day actually. And it was really early. It was, I would say, 2008, 2005 or something like this. And there was OpenAM from Sun Microsystems, this Open Access Manager, I think. And I had a chat with the people of the server, and they already back then talked about OAuth 1, and that they would like to provide it. So this was actually interesting. And this OpenAM is still around. Actually, it is a commercial product. Sure. But the OAuth early days, and what I remember also very early, if I say a proprietary implementation in Java EE application servers, I always wanted to move the implementation towards OAuth, because it was a standard back then, but it's not really well supported standard, right? It was there, but it was not natively supported. And so now we have JAX-RS and we have Quarkus, and you are the Quarkus committer, and you care about the security, right? So we have now OAuth 2, maybe. So this is the second.
OpenID Connect.
Yeah.
Built on top of OAuth.
Yeah, but maybe we should start with OAuth 2.0. You know the significant differences to OAuth 1, or is it too far back?
No, OAuth 2, you have a refresh token, right? The concept of the refresh token introduced in Open Authentication 2, right? Other than that, I think the Authentication 2 protocol is simpler, right? I recall with Authentication 1.0, it was like a significantly more sophisticated implementation requiring to complete the authorization flow, right? The flow. You have to. I thought it was depending. You were about to capture the signature of HTTP. The signature process calculation, as far as I recall, was including HTTP request method, possible query parameters, and I thought it was somewhat brittle. For example, the query parameters, there was no canonization process in place as well, and I thought I just recall thinking it was sophisticated. However, as far as I recall, Authentication 1.0 authors, they thought it was essential to capture for the HTTP security, to capture the precise kind of snapshot of the HTTP request, right?
Yeah, session fixation. I'm just reading it, right?
Yeah, queries, what query parameters were there, so that nothing is changed in the process. This is probably, but this in itself goes just beyond the actual authentication flow, and I thought maybe this is where they diverged. In Authentication 2.0, you just implicitly authenticate the users, right? But what OpenID Connect brought on top of this you now have a formal representation of the user authentication in the form of ID token.
Yeah,
Right.
exactly. So for me, the difference between OAuth 2 and OpenID Connect is that OAuth 2 just provides you a token which no one understands, and the OpenID Connect provides you a JSON Web Token which can be decoded, right? So this is like the...
Not probably not quite. So in Open Authentication 2.0, like there is a there is no notion of session as such.
Session,
right? You
okay.
just go somewhere, you authorize, then your application completes the authorization code flow by exchanging the code for tokens, and with OpenID Connect you have ID token just capturing the fact that you have authenticated, right? So in addition to access and refresh tokens, which you can get with Open Authentication 2.0, OpenID Connect gives you ID token capturing the successful user authentication. And this user ID token has lifetime, and you can build a session around the lifetime of this token on your own website and things like that.
But you could also do it with OAuth 2 with the access token. But
yeah,
because if you have the ID, access token is kind of a session, right? Not a session. I mean,
no. The with access token, they're about with authentication 2 is really about authorization, the main kind of concept. So you authenticate indirectly somewhere on some website, but access token gives the website you're about to access the right to do something on your behalf. This access token is not really about doing something on this website you're about to access, but you're giving the permission to this website do something on your behalf with this access token.
Forever.
Not forever, for some time.
For some time, okay.
The access token is time scoped, yes.
Yeah.
And this website can fetch some data for you, print something for you. But ID token is really like an instance of the fact you authenticated into this actual website.
But maybe you should cover the terms, because what we have the client, and the client can be the usual about the client is that the client is an app which we would like to access, right? So if this were, let's say, what we have, let's say we have a JCP Java Community Process website we would like to authenticate. This is the client.
Yeah.
Then we have the resource owner would be you or me, right? This is the end user is the resource owner, right?
Well, the website, if you talk about GCP, this is in OpenID Connect terms, it would be a so-called confidential OpenID Connect client.
Confidential OpenID client, because it needs authentication in OAuth would be it's not the IDP, it is called differently. How is OAuth called the server? It would be like the identification, because IDP implies OpenID Connect, and there is a more generic name. I think it is called like Authentication server, just, or Authorization server.
Yeah, possibly, and there also relying parts and so on. But the site we are authenticating into is a confidential OpenID client, and it's called confidential because it keeps the secrets representing the OpenID Connect registration privately. That's why it's called confidential. It can keep things like refresh token, which is a very powerful token, privately. If we're talking about single page application, which authenticate users into OpenID Connect provider, this SPA acts as a public OpenID Connect client, because it can't keep the secrets securely anywhere, like in refresh tokens, for example.
Well, we're just going with, is OAuth 2 usable without OpenID Connect in real world?
Yeah, we have several very well-known social providers like GitHub, like like Spotify, I think they're OAuth 2, Twitter. The totally OAuth 2 providers, they just don't know what OpenID Connect is. But the difference between it's still authentication, right? We are still letting users authenticate to GitHub, for example. But for frameworks like Quarkus, the authentication is implicit, right? Like the only the user can essentially verify that the token they're getting is valid, because they just need to access some API, or Quarkus can do on behalf of them to access user info information on their behalf. And these access tokens are often binary in OAuth 2 world, right? There is no JSON web token format, so you can't really verify them locally. So for some tokens, notably coming from OAuth 2 providers, you just have to verify them implicitly or by accessing some of the API from this provider services.
Okay. So what it means is you mentioned SPA and not SPA. SPA is not confidential or confidential clients. And what it basically means, I think, in the confidential client, I could go to Quarkus. Quarkus will do the OpenID Connect flow and provide back the token. And with the SPA, I would go directly to the IDP, get the JSON Web Token, and come back to Quarkus, right?
Yeah, like with SPA itself has some kind of script which will redirect you to OpenID Connect provider, and this SPA will get the tokens, not Quarkus. But then SPA will use access token to access Quarkus on behalf of the user. The same way, when we access Quarkus, the Quarkus will use access token on our behalf to access something else. So this is the general concept brought by access tokens and OAuth 1 and OAuth 2. That's where the revolutionary concept was, I think. Plus, of course, the fact the password has to be entered elsewhere, not directly.
But we could actually distinguish between access tokens and ID token, that we could say the access token is more or less a reference to the identity, or I mean it points to the to the data, and ID token already has the data, right? So if we have JSON Web Token, it already contains the data encoded, right? So like scopes and the user data and so forth.
No, not quite. Not sometimes users actually treat them interchangeably, but these are two conceptually different tokens. So ID token has information about the user, indeed, and if there's not enough information about the user, OpenID Connect provides user info concept. So Quarkus will get additional info from the OpenID Connect provider about the user.
And what you have to pass to the user info endpoint? You need a kind of a token to get the ID token.
Exactly, but access token, that's what it's about. It's about a given endpoint fetching something on behalf of the user. And access token, using access token to access user info from OpenID Connect provider is the real instance of this. So you just use access token to when I'm authenticating into Google or to Keycloak, I'm giving my permission implicitly already that Quarkus can use my access token if needed to access my user information. This is like OpenID Connect scope, and in the token. But of course, in the real world, the access token can have more scopes, like print or I don't know.
So it means I can pass the access token back and forth, and then I get authorized to access something. But what I can also do, I can have the access token go to user info endpoint, and I get the ID token back with the scopes. And this is more like almost like offline.
You won't get ID token back because ID token was returned once authorization code flow was completed. But you can use this access token to fetch user info, which will contain information already included in ID token and more.
Okay.
And you can then propagate this access token to other downstream services to access some other things needed by the application.
Okay. And if we have the SPA scenario, that the JavaScript front end just gets already the JSON Web Token, we could actually use in Quarkus just the microprofile JWT dependency. There is no need for OIDC, right? Then
OIDC Quarkus. So OIDC Quarkus OIDC extension itself, it supports two flows, right? Authorization code flow, right, which is the user authentications.
Well, we talk about right now, right?
But SPA, like if SPA authenticates users, right, it gets ID token, access token, but then it will use access token to send it to Quarkus as a bearer HTTP token. So Quarkus still needs to verify this token in order to allow the access to its services. So Quarkus OIDC extension can do this as well. Or you're right that you don't have to use Quarkus OIDC, but you can use, for example, in this case, small I JWT extension, which is just becoming a question of bearer token verification, right? And with OpenID Connect, you typically use local verification keys in JVK format, or you could, and this is a legacy from OAuth 2, or you could use introspection endpoint of the OpenID Connect provider if it supports it, to send the token over the back channel to introspect the token. And this is probably the other important difference of OpenID Connect from OAuth 2. In OAuth 2, if you need to verify the token, you need to introspect it, right? You need to send it to the provider, to OAuth 2 provider, to verify it, to confirm it's valid, right? And with OpenID Connect, you have a copy of the local keys, so you can do the verification with the public keys locally, so you don't have to send the token back and forth all the time, just verify.
So OAuth 2 means the introspection is the process of sending the token back to the server, to the how to call the server, to the OAuth server, the server says yes or no, and the OpenID Connect has more or less offline verification. Because you need a public key. You need a public key, and with the public key you can verify the authenticity. I think
exactly,
it's called, of the token, right?
Yeah, but it's not totally offline when the token key identifier cannot be matched. The application will try to refresh JSON Web Token keys from the provider and see if it can find the matching key again.
So the
which supports the key recycling.
But I think the verification with the key is also supported by SmallRide JWT and so microprofile JWT, right? So because you can specify the key and it should work actually, and it could be also provided by OIDC, right?
Well, the SmallRide JWT is in Quarkus. If you are only dealing with authenticating bearer tokens, you can use either SmallRide JWT or OIDC extension, right? Just OIDC extension is a little bit more involved. You can support both flows at the same time. You could have a so-called hybrid mode where you could accept bearer tokens, or you could authenticate users using authorization code flow at the same time. Things like that.
Okay, so we could use both basically. So you could
and we also have one more extension dealing with the bearer token authentication. It's called Electron OAuth 2. It's probably the most lightweight extension we have, but it can only introspect tokens remotely, I think, but nonetheless it's just one more option.
So basically, what Quarkus can do right now with the OpenID connection is OpenID Connect extension is either it can provide you the flow, so you go to Quarkus and it redirects you and provides you the tokens, or it can verify already existing tokens, which you probably need for SPA. And what I also understood is you could use actually the access tokens for machine-to-machine communication, right? So if you have two microservices without the user, so you would rather use the access tokens and not JSON Web Tokens, right?
Well, no, access token and JSON Web Token. They're not different terms, right?
Yeah.
Access. It's just JSON Web Token is a format, right?
Yeah.
JSON. It's an encoded JSON. But its access token can be binary or it's just like a database pointer, really, like a sequence of.
Yeah, the database pointer. This is what I meant. So you would use the database pointer format, like I'll call it like proxy or reference format, or you don't need to have the JSON Web Token, which already carries the values. This is what I meant.
All right. Yeah. So you're right. So while ID token or access tokens are two different types of tokens, you're right, totally right that. Access token can be represented either as a JSON Web Token containing all this information inside of it, or as a binary token. And specifically, as far as JSON Web Token is concerned, this is probably another invention of OpenID Connect, formalization. So the concept of JSON Web Token was known before OpenID Connect specification got it formalized, but JSON Web Token allows pushing scalability to the new levels, because OpenID Connect providers can put the information, like sessions, related information into ID token. Mm-hmm. And instead of keeping all of this in your own database, you let someone else keep it, like as cookies somewhere. Or
this is like caching, right? You don't have to access, the store all the time, because the entire information is passed back and forth.
Yeah, and if it's JSON Web Token, it's secured, right? It's signed. It can be actually encrypted as well, and you don't have to keep all the information inside the ID token inside your own databases. It's just like the storage, all the web stores this, and it supports scalability to massive levels.
No, nothing lost. So we can actually just proceed with the conversation. So the question, the access token, are there two names for an access token which has the data and access token which points to the data?
No, not really. No. So access token.
This is a pity, right? Because there's a huge because ID token is like value, and the access token can be value or a pointer, right?
Well, the reason for ID token always been in JSON Web Token format is that it just has to be used by the website, right? It has to be verified locally. It has to be efficiently processed, verified locally, and access token. I suppose the reason when access token was introduced by OAuth 2 specifications, there was no idea of presenting this in JSON Web Token format. But even today, many providers keep presenting access Web Token in binary format possibly for efficiency reasons, because the website which the user is getting authenticated to doesn't need access token to deal with the user authentication. It only needs access token to do something on behalf of the user. So as far as the content of the access token is concerned, it's like opaque tokens for all purposes for again websites.
Okay, the opaque token. This is the term from the spec. This is what they're saying, right? The opaque token is like token without meaning.
Yeah, opaque token. The format of it is of no interest to the website, and this is why providers prefer to use, many of them, for efficiency reasons, just prefer to use binary, opaque representations, short binary sequences, instead of JSON Web Tokens, which are fairly large, due to the claims and signatures and stuff.
But the opaque usually means pointer, right?
Yeah.
It could be encoded, but it isn't, because if you provide an opaque token, usually it would mean it would be another something like ID token, but in proprietary format, and usually it wouldn't be accepted, because the question is why you have a token with the value which is not JSON Web Token, right? So opaque usually means pointer.
Yeah, I suppose from the implementation point of view, it is a point. Yeah, points.
Very good. So that's actually great. So we covered. There are 3 flows, but 2 are actually only used in practice, right? In OpenID Connect, the code flow we discussed.
Authorization code flow, yeah.
What else we have? We have the implicit flow, right?
No, we don't do implicit flow in Quarkus. So we do.
But there is in OAuth. In OAuth there is implicit flow, right?
These days it's deprecated, I believe. Yeah,
deprecated,
so,
okay.
But in any way, implicit flow is for SPA only, right? So even because with implicit flow, the so as the called tokens are returned directly in the fragment or something like that, and it's not considered to be safe. So the 2 flows we are focusing on and Quarkus on is authorization code flow and to authenticate users directly, or bearer token authentication, right? And this is where.
So code flow and bearer authentication, they are the 2. Mm-hmm. And authenticating using directly would be like the basic authentication with HTTP, right? This is what I mean. What do you mean? Or is it without OpenID Connect?
Yeah, like we have several other authentication mechanisms, like basic authentication. We have the legacy form authentication. We have web authentication. The web authentication created by one of my colleagues, Steph, which is leading to the whole kind of passkeys area and so on.
Exactly. So interesting. So we have so Quarkus has multiple security providers. The most, I would say, powerful one maybe is OpenID Connect, right? There's a lightweight variant, small JWT and Electron security. This is the lightweight, most simple and
we recommend OpenID Connect because single sign-on is like essential in any major production and or even bearer token authentication, and this is why we recommend OpenID Connect, or if you can't use this small JWT, to use it for your security. But indeed, other options available, and basic authentication in secure networks is a very reasonable, simple approach.
What you only have to cover is the contents of JSON Web Token, because very briefly, because what's inside is the scopes, and scopes are more like roles, I would almost say, right? Or no, roles is my capabilities, but usually you could map them to roles, right?
Well, yeah, JSON Web Token, technically it has the headers representing information how the token was secured, for example, and how the sequence has been created, and key identification. And then the actual content is typically claims, right? And scope is one of those claims, and it's kind of tricky. Scope may not necessarily can be used as a role, but it can be used more like a permission. So for example, role is admin, right? And permission is read or write. So it's kind of different. And my colleagues have implemented both permissions and role-based access control. So in Quarkus.
What do you mean implement both?
Yeah, you could use
because scope is just so the scope's like a hash map. There's a key values, right? There's just information, and the question is how the information is mapped to something Quarkus understands.
Yes,
right? So
exactly. So there can be role-based access control. Like this method can be allowed to be accessed only by admin, for example, or user, and so on. Or it could be permission-based control. So like if the token has a security identity in general has a permission to write or read. That can then the access the request can go ahead. So yeah, that would be, and scopes would be probably closer to the permission-based control as opposed to the role-based control. Though users, if they want, they can map scopes to roles in Quarkus. So they can say that.
But permission would be like file : read or something.
Yeah, or whatever, whatever custom permission there is. Yeah.
And you have to configure the OIDC extension to say what you would like to have, role or permission, or there's no difference?
Well, it depends on what the application wants. If so, for example, like most providers, they probably can do scopes by default, right? Because it's a scope is a well-known concept in OAuth 2 and OpenID Connect world, and scopes would be probably good for the incremental authorization idea driven by companies like Google and so on. So, like, you go to the website and you don't buy kitchen sink immediately. So you go onto the website and then bit by bit you add permissions to access. You approve permissions to access different parts of the website and so on. But roles, they can be pre-configured in advance in the provider, and it's really like a more coarse-grained access control, really, like with roles. It's about admin.
But how you see this in source code? What I'm asking, because scopes, I see you could use roles allowed annotation, or there's directly mapped to Java concept, but or microprofile concept or Quarkus concept. But what's about permissions? Do you have a permission annotation, or how you map the permissions to permissions?
Yeah, you're right. So we have permission allowed annotation instead of roles allowed. So it's called permission allowed.
This was the question asked.
And then security identity augmentation can map the current identity can prove that the current identity has certain permissions, but including scopes. Though we haven't automated yet, just made it automatic mapping of scopes to permissions, but it can be done in the augmentation layer by users anyway.
And okay, and the permissions are Quarkus annotations. Are you planning, to put this in microprofile whatever spec?
What kind of spec even would it be? It would be a microprofile JWT, for example, because it's more like
microprofile permissions,
right? Permissions, and specification process is hard, and it's so I think.
Yeah, but you like it, right?
Well, I used to like it more when I was younger.
Okay. Okay, got it. So, but I think really in microprofile, permission spec, a lightweight permission spec is missing, right? This would be nice because the Jakarta security could be extended with permission concepts, one of both, because it doesn't matter for me. Microprofile and Jakarta are interchangeable.
Well, yeah, it's a good idea. I'm not 100% sure if they don't have yet something related to the permission concept in Jakarta. This is like they had like Java provide the whole permission thing, but they don't have this permission allowed kind of annotation. Yes,
exactly. What I also wanted to know, how important is actually the standard? So if you implemented something Quarkus with security, do you try to do microprofile or Jakarta first, or say, okay, we just do whatever is necessary and then see how it's put to standard, so how you're dealing with microprofile and Jakarta.
I think it's over what's like in the modern software development, I think, and it's probably implementation like Spring in particular, have proved that you don't have to implement a specification in order to succeed, right? And while at the same time, we also understand that it's important for customers, for users to be set up that won't be locked at a certain level to software and to a given provider, and this is what the value of the standard is. But I think the times where it was only standards and nothing else has gone, because
this is true. But I can give you feedback from my project with larger clients. For instance, we use Quarkus because Quarkus implements microprofile. And this is, and we try to restrict, whatever we're using to microprofile because there is no need to be depending on Quarkus extensions directly. And why not? Because if you think about this, there are hundreds of Quarkus extensions, and because there are hundreds, this is no matter of time. Then some of them will be deprecated or die. This is just, it has to happen. You cannot have more and more extensions without deprecating the old one. But if you code against microprofile, and microprofile is used in OpenLiberty and others, Glassfish and Pyaras and so forth, so the chances are no lower that they will disappear. So I would say, supporting standards is really smart.
Yes, of course.
For instance, I realize Micronote, this is a competitor of Quarkus, but I don't use it a lot because it doesn't support lots of microprofile standards. And I really don't like to learn proprietary stuff just to use it. So I would say, if I know it, why I should learn strange things. So this is what I just feedback from the field, that some larger clients, or not even larger, some clients just really care about the standards.
Absolutely.
Because they're so this is, but you have to be innovative, so you can push forward. But I think then it's time to contribute back to the spec. This would be the perfect case.
I
Right?
suppose, yeah, it's a good point, right? So the standards, the value of standards that customers can be assured that they can write code which can be ported across multiple stacks.
Yeah, I say always learn once and develop everywhere. So this is my thing, I just learn the standard once, and I don't care which servers, I can just apply my knowledge to everywhere, which is really valuable. And people, like-minded like me, there are some developers who also have similar thinking. So.
Yeah, it's just the conflict in today's software development world that the specification process is slow, and projects would like to fly fast, really fast, and it's really that's where the conflict is. Like the people just like to write things quickly and put it to the community and make them happy, without waiting for a year.
But with your experience, I think you can provide very quickly more or less stable minimal standard. This is what I'm talking about. It doesn't have to be complete, but at least start with one annotation. Why not? Permission allowed or whatever. And I think with microprofile it can be or Jakarta EDIS, you can be really fast and pragmatic. And actually, I don't know if they remember the JSR330. I think the Rod Johnson of Spring, they contributed and pushed forward the standard in 6 weeks. So it was like the entire dependency. It was like a hack, but it worked back then. And the inject standard, the injection. So just as feedback to the general, be careful, because if you just pushing new stuff in one point of time, I say, okay, why I should use Quarkus? I mean, if I go to pick because really the huge selling point of Quarkus right now is I'm in migration projects from Payara and Whitefly, whatever, and I say, okay, go to Quarkus because the code is compatible. But if you push too far, I would say, okay, then why not to take Micronote, right? Because we have in both cases the same
like an expert teams and who are actually active developers as well, and where we really actively involved in whatever activities are there in microprofile right now, and I think like we are talking and discussing things, and we are not just my understanding, we are not going anywhere as far as standard participation is concerned. Yeah, but you have a good point that try to be more proactive, I guess. So that's what we try and.
This is also why I like Jersey. Was Jersey first or JAX-RS? There's nothing against the implementation first and then standardize it, because it's really boring to work with spec first. This is what I hated. But you could actually think about the spec, write the implementation and then abstract it out to the spec, and this worked beautifully, I would say. So this is why I'm asking.
This is we have to pick a good point. I agree.
Very cool. So now I asked you last time about passkeys. Okay. This is the new standard with from proposed by Apple and Google. My understanding is this is more like SSH, more or less, right? So this like the key is stored in a secure enclave and synchronized across devices, and this is how you access the page. So do you know what it is, and will it be supported by Quarkus in one point of time?
This is a very interesting point, and I'm actually thinking about what would be the next big thing, right? And I think this is a big thing, but it won't be the very next big thing. So this is is a very big thing in the as far as passwordless authentication is concerned. And you're right, it's a really big thing, and like you said, the website will keep you register your device, and website will keep the public keys, and you authenticate anywhere with one or even more devices with the case of passkeys, without needing to know any password to remember it. This is really streamlines and makes things more secure. So this is very important thing, right? And like I said, we support web authentication, right? Which is with web authentication, apparently you're tied to a single device, but nonetheless the concept is the same, right? So it's a passwordless authentication. But I think what is important is that I believe all of this will be happening at the OpenID Connect provider side, right? So while we support direct web authentication in Quarkus, I think most providers, even like Kiklark, for example, just when you're about to authenticate to OpenID Connect provider, username password is only one of the mechanisms. So they will offer you an option if you would you like to use web authentication, and if you want, you will be asked to register your device and stuff, and so on with passkeys. So I think Unity, one of the OpenID Connect providers, I think they support Apple passkeys already at their side. So the point is that as far as framework like Quarkus is concerned, we would like sophisticated, focused providers such as OpenID Connect provider to deal with all of the complexities of this, right? But the next big thing will be verifiable credentials. Believe me, it's verifiable credentials is the next big thing. It's about proving your credentials, your driving license, your age limit, whatever else, electronically. This is the next big thing, and there's already it's a World Wide Web specification, and there's already a JSON web proof and set of specification building on top of JSON web token and stuff like this. It's going to be big. So the idea is that you, for example, let's say, imagine you are about to access Quarkus, and Quarkus includes a scope. When redirecting back to OpenID Connect, provide your credentials. You go into the OpenID Connect website, you authenticate as usual, and then OpenID Connect provider asks you what type of credentials do you want to include in your token, and it will be not JSON web token, it will be JSON proof token, for example, just new type of token, and you will select from the list. You'll be offered a choice of verifiable credentials, such as I'm older than 21 years old, for example. I'm having a driving license. I'm allowed to fly a helicopter, for example, things like this, right? And you're redirected back to Quarkus. And now Quarkus can verify. So, for example, let's say a health executive is built on top of Quarkus. And that can verify that you are older than 21, and then you can do certain things while accessing so you don't have to present this proof like as a document, physical document. It's all electronically verified and proved, selectively exposed in the JSON web proof token. And this is going to be the big thing, but it will take probably another few years for it to go mainstream, really. But it's going to be major.
Do you know Andrew Lee Rubinger?
I think so. I think he did the JSON canonicalization spec. No?
He did. He was one of the evangelists on Whitefly, and he also did CDI. Worked on CDI.
Oh no, that's I did good. So I thought about
Red Hat.
Well.
But he worked on Red Hat for Red Hat. And now he works for TBD, and I already had it on the show. And he worked for Decentralized Web.
Can you share the name, please, in the chat?
Yes. This is the name is Andrew Lee Rubinger.
All right, okay. So there's another surname which kind of rings a bell, but about the JSON canonicalization.
Maybe he also did it. And by the way, there's any way to canonicalize JSON with Quarkus or Quarkus extension?
No, but yeah, there is a specification and there is a library, I think, which allows to canonicalize this. But
which library are you using?
no, we don't do it. I just I know there's a spec effort which has been done, JSON canonicalization, which can do it, and there's a library to support that spec. I just haven't used it.
And the company he's working for is called TBD, and this TBD is like social link data, and from the solid, and this TBD is like a blockchain, and I think they are using exactly this for finance world, to have this tbd.website is the name, and if you go to AXFM, you will find Thinking About Decentralized Web with Andrew Lee Ruminger, a nice guy. And he worked on Achillean testing and shrink wrap. So he was, the Achillean testing guy.
Right.
The exactly. And also on dependency injection. And so he's already working on it. And he's the TBD is a company from, how it's called? Block, I think, is the new name of the company, and back then it was called differently. It is a payment provider.
This might be more related to blockchain, kind of.
It is almost like it's a kind of blockchain, but the outcome is the same. So they try the decentralized identity, which is a standard in a blockchain, which is maybe the backbone of this, what you said for the front end.
Yeah, it
right?
might have. So the verifiable credential concept, the specification is created based on the practical application doing things, and you're right, it might have been one of the inputs into the specification.
Yeah, cool. So what are the new security features you are working on Quarkus? Is this something new, or just to make everything more stable? And
yeah, we're always very busy in Quarkus, like in related to various security questions. And issues, OpenID Connect would probably the busiest extension security-wise. But as far as the new security thing is concerned, this a little bit stalled at the moment. But we would like to support like inclusive authentication, which means that more than one authentication should happen at the same time. So, for example, if you use mutual TLS and you not authenticate users over mutual TLS, so it would be mutual inclusive authentication. Both MTLS verification has to pass and username password authentication has to pass. And we would like to make it much more simpler to support multiple tenants in OpenID Connect. So, for example, if you authenticate users into Quarkus using Twitter, GitHub, and OpenID Connect and Google, how do you distinguish between which configuration should deal with the current request, right? So we have Quarkus supports static and dynamic configuration, but we're focusing also on the convention-based configuration where you don't even need to provide any dynamic resolution of whether it should be Google or tenant or Twitter or GitHub authentication. It's just based on the convention that, for example, when you authenticate, the name of the provider is the last path segment in the request URL. Would be, for example, login /Google, login /Twitter, things like this. And if you follow the convention, Quarkus will select either correct configuration for you to drive the authentication process. Things like this. Stabilizing, simplifying, and thinking about doing new things like inclusive authentication. Certificate renewal as well, automatic certificate renewal. We're working with experts from Wildfly who are going to help out. So a lot is happening.
Certificate renewal is really important because this is really painful. So you mean the SSL certificate renewal, right?
Or that's something we would like to explore further. Automatically.
Yeah, very good. Yeah, perfect. So where people can find you on the internet?
They can find me at Sberezkin Twitter tag, and I'm hoping to do many more tweets going forward. I used to blog a lot, but these days I don't. I used to have a blog musings about web services.
Okay.
It was running for a long time, and but it's kind of gone quiet for the last few years.
Okay. So it was pleasure. So we learned about OpenID, Connect, and passkeys and the future, and Quarkus.
Thanks very much, Adam, for inviting me again.
Thank you.